Okay. For trinomials, we're going to, just like we did for factoring in grade 11, we're going to factor this. In grade 12, the expectation is you can factor this directly. So if you have developed a factoring strategy from grade 10 that you love, perfect. You can do that on a separate piece of paper, but just write the answer down. If your method from grade 10 you've forgotten, well then it wasn't a very good method for you. So I'm going to hopefully just reintroduce to you a very straightforward way of factoring, which is, it's not guess and check, but it's basically look at it and check to see if it works. You're not guessing, you're just looking. So first thing you're going to look at is the first number, which is 2 sine squared. The 2 sine squared will come from these first two numbers. And really, there's no option. If we're using whole numbers, the only possibility will be 2 sine theta and sine theta. And this will give us our first ones. The last numbers, when you multiply it all out, will multiply to give you your last number. And this is beautiful too, because with a 1 there, whew, there's not many choices with whole numbers that work. The only way to get this last number of 1 would be to have 1 times 1. The only way to get the first number is 2 sine theta and sine theta. Now, the middle number is a combination of when you multiply these two and these two. Now, this will give me 2 sine theta, this will give me sine theta. I need a negative 3 sine theta. Can you see that the only way that would work is if you had a negative 2 sine theta and a negative sine theta combined to give you a negative 3 sine theta. In English, sometimes we use the following to say what we're doing. These are our outside ones, so we use O, and these are the inside ones, so we use I. And sometimes we use the acronym FOIL, that you've multiplied your first ones, you've multiplied your last ones, and you took the outside ones and the inside ones and combined them to get what you started with, okay? But if you use this strategy of looking at your first ones, what would work? Looking at your last ones, what would work? And if you always check after you factor, does it actually give you what you want? If it doesn't, it will not take you very long to make some adjustments. If it does, perfect, you're done. And again, the reason we want to factor is because now this has changed to a multiplication here. And when two things are multiplied and equal to 0, either the first one has to be the 0, and it wouldn't matter what the second one is, or the second one is a 0, and it wouldn't matter what the first one is. So if the first one is 0, and I'm going to write this in purple because you won't write this down, you will do this part in your head. In your head, you will think, if 2 sine theta minus 1 is equal to 0, can you see that you could move the 1 over and divide by 2 and get sine by itself to be 1/2? The purple part you will do in your head. You can't see the half?
No, I can't see it.
If this is like this, and I want to get this part by itself, I put the 1 on this side by adding. And then to get rid of the 2, I divide.
Oh, yeah, okay.
Okay? Same thing here. Sine theta minus 1 is 0. You will just go directly and say, well, if it's equal to 0, then the sine theta would have to be 1. Is this on your pie plate? What family gives you 1/2? That'll be your reference angle. Pi over 6, right? And that's one I like to memorize, that sine of pi over 6 is 1/2. Therefore, if it's positive, it'll be in quadrant 1 and quadrant 2. That looks like an axis family. Is your y-coordinate ever 1? Yes. So this would be a non-calculator question. We factor it. The values are from our pie plate. We just have to recognize the families, the values, so we can tell which families they're from. And then you can use your cast rule, that sign is positive, so it's in quadrant 1 and quadrant 2. Question?
The first, like the two brackets.
Yeah.
The conversion from the top to dots is something called what?
Factory.
Hmm?
Factory.
What exactly happened?
Do you know that if you have if I have this and I want to multiply it out, I have to do this, 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 and this,
Yeah.
right?
I know that one.
Okay, so then this and this will give me x squared, and then minus 5x plus 1x minus 5. So these two are the like terms, so we can put those together to get minus 4x minus 5. This is expanding. Working backwards is factoring. So if I gave you this, and you had to work backwards, the idea is your first ones give you x squared.
Mm-hmm.
Okay? My last ones give me 12.
Mm-hmm.
I have some options. I could do 4 and 3.
Mm-hmm.
But when I check the outside and the inside, that would give me 7.
Mm-hmm.
I look at a different option. It could be 12 and 1. I know I'm bothering you by picking all the wrong ones. But if I did 12 and 1, my outside would be 1x and 12x would be 13.
Mm-hmm.
I'm like, okay, 1 and 12, 4 and 3. It's bothering you, isn't it? 6 and 2. Yes. And now I get 2 and 6. Yes, that makes 8. And so this is factoring. Going from this to the factored form.
Okay, that's something I can work with here.
Okay? And the best way to do it is, in my opinion, for grade 12, because they won't give you super complicated ones. And if they get super complicated, you can use the quadratic formula. In fact, we're going to do one today that does the quadratic formula. And you're looking like, I forgot the quadratic formula. It's on your formula sheet, but again, you have to have it memorized for next year, so may as well start memorizing whatever formulas come up. Start memorizing them already as best as you can. So let's look at the next question. Ooh, there's another level of difficulty. With negative 3 sine theta minus cos squared theta minus 3 equals 0, if you were solving this last year, these would not have trig functions, they would just have x's and y's. So I'm going to, since sine is your y coordinate, and cos is your x coordinate, this is like trying to solve this equation. But we have a problem because there's 2 variables you don't know. You don't know the x, you don't know the y. Right? This is called a systems of equations. If you have 2 things you don't know, how many equations do you need? 2 equations. And on the tests or on the exam, they won't give you the big idea as the hint, but the big idea gives you a second equation. But it's not told to you directly. So I can't solve D right now because it has 2 trig functions in one equation. However, if I use the big idea, I could either, and I'll write it out here, I could either get the cos squared theta by itself by subtracting the sine squared theta to the other side, or I could get the sine squared theta by itself by subtracting the cos squared theta to the other side. And here, I want to replace this. So I will use this equation, and this is how it will look. I'll rewrite the equation. I've got negative 3 sine theta. I'm going to put minus, then I'm going to put a set of brackets, and I'm going to write minus 3 equals 0. So the only thing I did was, instead of the purple box, I just left it out. And I can write, instead of cos squared theta, I can substitute in 1 minus sine squared theta. And now I have an equation with just sine. This negative would get distributed. So I'm going to combine some like terms and rewrite it when I notice I have a quadratic equation, so I'm going to write this positive sine squared first. Then I'm still going to minus the 3 sine theta. And can you see that you have -1, -3, those are like terms, I'll combine them to get -4. And here's your practice for factoring. Try it first on your own. Can you write this as two things multiplied? First of all, for the first one, really easy that it had to be sine theta and sine theta. Okay? Now with the 4, you could choose 2 and 2 or 4 and 1 to multiply to get 4. Okay? If I choose 2 and 2, my outside be 2 sine theta, inside 2 sine theta never makes 3. So right away I know it's not going to be 2 and 2. If I go with 4 and 1, outside is 1, inside is 4. If I would subtract, I could get 3. Now I need to get a -3. Does it make sense that if I have a -4 and I add 1 sine, I would get -3? So again, we use the idea, we check our answer, and that will make factoring really easy for you. Still takes practice. Which means we're now multiplying, so sine theta can equal -1 here, and sine theta can equal 4 here. Now, when the values are on your unit circle, like -1, so on your unit circle, it will be non-calculator for that part, and you're expected to say, all right, axis family right, what angle gives us -1? 3 pi over 2. And now, is 4 on your unit circle as a y value? No. So normally you would think this is a calculator for this side. However, this question is all non-calculator. How do you do this if you don't have a calculator? And it's not on your unit circle. So I'll go with, well, kind of.
You can't.
You can't. So we just leave it blank?
No, it's a non-permissible value.
It's a non-permissible, it's not possible. You have to say it's not possible. Why is it not possible? Well, if you're stuck, you could draw a picture because you know that sine, right? Sine is the opposite side over the hypotenuse. I can make this a fraction by making it 4 over 1. If I drew a triangle, that would be the opposite side is 4. Here's my theta. My hypotenuse would be 1. And that should make you feel like something went wrong. Why does that feel so wrong? Yeah, the hypotenuse is bigger than the side. That's not possible. Okay? So this, anytime for sine and for cosine, you get a value bigger than 1, you can say without a calculator that it's not possible. Tangent could be bigger than 1. Because opposite over adjacent, you could have one side could be longer or it could be shorter. Okay. More difficult factoring one. First of all, the whole idea of factoring only works when you have one side equal to 0. So first step in this question, you have to make one side equal to 0. Then when we go to factor this one, we run into a little bit of a dilemma. On all the other ones, we've started with the first value, but this time our first value is a 6 sine squared theta, which is a little bit problematic Because you can get 6 in more than one way. Can you see that it could be 2 times 3, or it could be 6 times 1? So option 1 is you go with one of them, and you see if you can find something that works. If it doesn't work, go to plan B and try the other one, and see if you can find something to work. And if it doesn't work, go back to plan A thinking maybe I made a mistake in plan A, and try it again, okay? But what I would do in this one is, since the first one has more than one option, I actually look at the last one first. And I'm like, it's a 1. I at least can feel quite confident that if it's factorable, those would both be 1s. That's a good thing. And now that you have those ones, now if you go back to your first one, your guess and check or your checking goes a lot quicker. If I tried 6 and 1, can you see your outside 6, your inside is 1? Does that ever make 1? No. So it appears that 2 and 3 is going to be our best option. Now I need a +1. Can you see that the 3 would need to be positive? Positive 3 in the inside. Subtract 2 from the outside. Double check everything, multiply it all out again to make sure everything matches up. One of the greatest strategies for factoring when you're stuck is at least make the first ones work and the last ones work and multiply it out and see how wrong you are. You know what's the most frustrating thing as a teacher when I tell a student to do that strategy and their first guess is right? I'm like, you were supposed to find one wrong and then you'd be able to adjust, but you just happened to guess the right one. And that sometimes happens too. But that's why checking it is so important. Now when we split this, if this one's equal to 0, you move the 1 over and divide, you get -1/2. If this one was equal to 0, you move the 1 over and divide, and you get 1/3. This value is on your pie. What's your family? That'll tell you your reference set. And then since sign is negative, according to the cast rule, sign is negative in quadrant 3 and quadrant 4. So we would have 7 pi on 6 and 11 pi on 6. 1/3. It's not bigger than 1, so we can't say not possible. This would be a calculator question on the exam. Because this side, you would have to take out your calculator and do sine inverse of positive 1/3 to find your reference angle. And then you would take all those decimal places. Since sine is positive, it could be in quadrant 1. If the question doesn't, I just put ... because it keeps going. If it doesn't say we round to 3 decimal places, I think it's like 3, no, it was 3, was it 3, 3? I think it rounds to this, right? Is it 3, 3? It's like this, the decimals?
3 repeated.
It's not 3 repeated. Try it on your calculator. I'm just going from memory. Yeah, sine inverse of 1/3. You don't have that memorized?
Oh wait, I thought you just know 1/3. Never mind.
No,
I didn't know
1/3
is not 3
1/3 is 0.3 repeated, but sine inverse of 1/3 is 0.339. And then if I do in quadrant 2, if I take pi minus this number, I think you get that, 3 decimal places. Yes? Good? All right. Sometimes I wish I couldn't remember numbers quite as well.
You wish you could fill your brain space with something else.
Something else.
How many of our names do you remember?
Rowan, Tom,
Mine.
Really? I'm good. I'm working on it. I'm doing good.
You were 2 rows ahead of where Rowan is.
Okay. So, this is another one that we could factor. I'm going to make, what letter are we on? E. We're going to make an F. And this will be the most challenging of them all. Let's do one that we can't factor. There we go. Nice and not factorable. Right? On your formula sheet, they have the following. I think it might even say this.
A squared plus B.
AX squared, sorry. For AX squared plus BX plus C equals 0. X is equal to plus or minus B. No, negative B. There we go. Negative B plus or minus the square root of B squared minus 4AC, all divided by 2A.
So would our theta be x in this?
Our X is going to be tan theta. Maybe I should have, let's just add another number. You can put a 2 in front of yours. Just make sure it's still not factorable. Might be factorable, unless I make this 4, then I think it's not factorable. There we go. There we go. Sorry, I want to change the numbers just so we have different. I didn't like that we had A was 1 and B was 1. When I make a question up, I like to have all different numbers. So, what we would do, we don't have an X, we would write tan theta equals, because that's instead of X. Our B value is 1, so you would have negative 1 plus or minus. B squared would be minus 4. A is 2, and C is negative 4. All over 2 times A, 2 times 2. And we would simplify this and get tan of theta, negative 1 plus or minus the square root. This is 33 over 4. With that plus or minus, you actually get 2 equations. You get tan theta equals negative 1 plus square root of 33 all over 4, and you get tan of theta equals negative 1 minus the square root of 33 all over 4. All right. Is this a calculator question, or is that number on your pie plate?
I know, it's on our pipeline.
It is not on our pie plate. So we're going to need to find the reference angle. First of all, I'm going to go to my calculator and just see what that, maybe before alpha y equals. I'm going to just write a negative 1 plus the square root of 33 over 4. I want you to see maybe I'll take some time to actually write that out. Tan of theta equals 1.18. I want you to see that it's positive. And on this side, I'm going to type in the same thing into my calculator, but just switch that to a subtract sign. Negative 1.68. Perfect. Okay? I want you to see that because one is positive, one is negative. When we go to find the reference angle of this one, I can go tan inverse of this one, and I get my reference angle 0.87. And so theta would
Interruption
equal,
again, a big thank you to all the groups that presented for student council. We will have voting tomorrow morning as well as at lunch hour and just past lunch. We're trying to tally the votes. Hopefully we'll have the results by the end of tomorrow, if not the next day. But thanks again for everybody to do that and come out and vote tomorrow. Thanks, Huskies. Have a great night.
and then I would do pi plus my answer, 4.012, as my second. This one's going to be a little bit trickier for your reference angle, because when I go tan inverse and I need to do this one right there, for reference angles, you never use the negative. So I could either use my cursor all the way back and delete that negative, but I think it would be quicker just to multiply by -1 to make it positive. Now when I push enter, I get the proper reference angle, 1.035. And on your calculator, the store button is really helpful. So I'm going to store that as x. And now it's going to be in quadrant 2. So that's pi minus x. And in quadrant 4, which is 2 pi minus x. 2.106 and 5.248.
I'll see you tomorrow.